Oluwadollars needs to jump from the tree to his car. So let's assume this is the tree. Don't mind my diagram, and this is Oluwadollars, the caricature diagram for Oluwadollars, and this is where his car door is. Of course, you have seen how the car is, so don't mind my diagram anyway. So this is the tires, and he has to jump from here straight to his car, inside the car. Remember, there's a lion somewhere here, so if he needs to escape this lion, of course, he has to jump from this place down to his car. And this motion is called projectile in physics. So you've heard of projectile in physics. This motion is called projectile in physics. Now, when he jumps from this top to the car, his final velocity has to be 0. V has to be 0. If V is 1 or V is 2 or V is minus whatever, that means he's going to bounce. So once he enters the vehicle, he closes the door. But if V is not 0, once he enters the vehicle, he bounces. And once he bounces, this lion has taken him. So V has to be 0. Now his initial velocity has to be something that can move him through this projectile motion, through this trajectory. This is called trajectory. Through this trajectory down to that. So let us assume his initial velocity is u equals to 10 meters per second as his initial velocity. Now what we are calculating for now is the angle he's going to jump with. The angle is going to jump from this particular tree. That's what we're looking for now. So his angle is what we're looking for. Now let us say from that video, the distance between the tree and the vehicle, let's say it's 10 meters. 10 meters, okay? Distance between the tree and the vehicle, 10 meters. And the height of the tree is, let's say, it's not too high, 1.4 meters. Okay? Now we have u as 10 meters per second square. We have the distance between the tree, foot of the tree, and the vehicle, which is 10 meters. This is called our range. R is equal to range. So R is known for range, and this is our height, or you can call it maximum height if you want to. So we can use the formula for range to calculate this angle which Oluwadollars has to jump with to be able to get to this particular place. So we use the formula for range as u squared sine 2 theta over g. So we put in our values. Range is what? 10 meters. So we have 10 meters equal to our u is what? 10. 10 squared sine 2 theta over, remember g is 10 meters per second squared. Abi? Yes. So 10. So we cross multiply so that we can be able to get our theta. 10 times 10 gives us 100. Is equal to 10 squared. 10 squared is 100 as well. So 100 sine 2 theta. So this can divide this. We're left with 1. So 1 is equal to sine 2 theta. Of course, we find the arc sine of 1. That means 2 theta is equal to the sine inverse of 1 when this sign comes here. That means 2 theta is equal to what? 90 degrees. To calculator. That will give us that theta is equal to 90 degrees divided by 2. This 2 leaves here, it goes to the bottom here. So theta is equal to 90 divided by this 2. So theta is 45 degrees. So I bet you if Oluwadollars jumps at an angle of 45 degrees with an initial velocity of 10 meters per second squared, he is going to land inside his vehicle without bouncing. Yes, he can try it. So thank you very much. Now for more of such amazing content where we solve real life issues using mathematics, physics, and chemistry, to subscribe.